All right. What's up, Twitch? Let's make sure this is working. Yep. Yep. Yo, hey, there's already people here. Or that's from earlier? I don't know. Oh, it must be from Connor's stream. All right. Here we are again, 598s. I am you. Okay, so we are on kernel exploitation. I can see everyone is basically done 6, 7. So what I'm going to do is just continue where we were on level 6 and go through that. And I think the goal here is we want to get to a point where we're overlapping the message object with what we have in there. So let's do a new window. Boom, 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 boom. Okay, practice mode. Oh yes, new haircut. Thank you, stream, for noticing. At least tells me there's one person alive somewhere out there. All right, hacker. Which is saying, I am stuck on this challenge. I could use some help. Okay, I didn't actually want to do level 7 because I was already doing stuff for level 6, but that's okay. Should be the same basic idea. To double check that, let's check out this in our handy dandy desktop. And I actually want to steal it, SCP. Oh, come on. With no flag command. Okay, thank you. Oh, whoops, see, I missed that and that. Boom. See, syntax important, kids. Okay, got that KO. Let's load it up in her. Get a new IDA. Yes, yes. Okay. ioctl. Okay. Copy from user. So there. Okay, I see. So hex. Interesting. Okay, so we only have copy from user, whereas last time, let me see. Shoot. Okay, what the hell is that? Okay, which in the other one, yes, we had this flag command. Okay, great. So the flag is probably is still red. Is it somewhere? Is it somewhere? We don't know. Is this where we have to like actually pop things? Okay. Oh yeah, this is cool. So there's not even any flags in here. You got to get them flags yourself. Okay, so that means on open, we kmalloc trace into this kmalloc cache 51. We showed how to do that. Let's double check. I think it should be the same 1D0. We can debug and figure out how to get there. That's where we ended up last time. Cool. So this is the kmalloc cache into private data, and then ioctl. We have private data here. Okay, so this is our free command. And this is our copy from user, but we don't have that flag command. Cool. Sweet. Okay, and there's no overwrite because the size is checked correctly. So the only issue is the use after free. Okay. Cool. So let's dig in. Feel free to keep chatting in the chat about the challenge. Maybe I'll pay attention to it. Probably not. Let's start. Okay, great. Okay. Let's see. I'll need two. Oh yeah, I already remember that. I will need tmux. let's see, new session T test. Oh, please work. Oh. Okay, but Tmux uses B, but that's okay. I will persevere. Actually, screw that. No, it's still the wrong one. Okay. My environment ain't right, then I ain't right. Okay, let's do this because I know this works. OBU, demo. Sure, update, why not? There we go. I use control character as A, so control A to swap between these windows. Okay. Okay, great. Okay, so now I have my SSH window, debugging. Okay. And let's, oh, I didn't get any of the addresses, so that's not going to be helpful. Should be able to continue. All right. Oh, somebody's asking how to do KASLR. There was this is 2024, March. I wonder. Oh, where's that notes thing? Oh, what the heck? There was one that just came out, like literally. Sys kernel notes. Sys. Yeah, okay. Okay, let's look at this. Oh no. Wait, where is it? Oh no, maybe Connor did fix it. Oh, it's already been fixed. Bummer. Okay, yeah, so you try the easy thing that works. Okay, but besides that, okay, let's go back to where we wanted to be. Let's see where we are. So I wanted to do reset if you ever find yourself in a weird case like that. Sudo cat proc k all syms grep heap. Okay, let's go there. We should already have a file open. I'm going through crypto hack, maybe as you can see. Hopefully this doesn't spoil anything for anyone. SSH. Okay. Okay, I'm calling this level 6, whatever, it's okay. We will say this no work. So we only functionality free without clearing, which we know is this last one. Again, this is like a weird decompilation thing. You gotta be very careful staring at this. Command is not equal to this, so that means this will only happen if this command does equal. And it's not allocating private data. Okay. Right on the free object. So free the private data, allocate a message that goes in our cache. These should be the same pointers now. Overwrite the message with whatever we want. Profit. Okay. So on our previous notes, we had kmalloc-cg 512, which is the cache line that we are allocating from. So we free the private data, allocate object X. Oh, this was like another idea that I had. Oh, yeah. Okay, I'll delete that. Allocate message into kmalloc CG512. Okay. Profit, and then we'll have to, of course, here we'll have to like overwrite message object very carefully. Okay, so flag copy don't exist. Let me just double check that these numbers are the same. It's nothing worse than trying to compile something and the numbers don't add up. Free is 5703. 5701 is copy flag from us, and there is no flag copy here. Okay, so here's the request. So I am freeing the private data here. Why in the world? Oh yeah, that's right, because I was using Emacs on that remote server, and all of the formatting is messed up. Okay, wow. Oh, that's why trying to use other people's tools or other tools is so difficult. Okay. So now we need to allocate a message that goes into our cache. Okay. Okay, bang, bang. These are going to drive me absolutely crazy. Okay. So now we need to figure out how to allocate a message that goes into our cache. So let's go. Oops, hello. What are you doing? Okay. Let's go back here. We'll look at the slides. So it's this one. Can't remember. Okay. Nope. Here. There we go. Message. How do I think it's like p-type. Oh, in GDB. Am I GDBing somewhere? Okay. Because I know we want to break here. And I also want to look at what this message looks like. Sick. So I really like using this because you actually use the types that are in GDB, so you can see everything. So, okay. So this is a struct, and this will help us when we eventually go to do our own. So this is a struct. It has pointers to next and previous, a type, and this MTS, I believe, is the size. And message segment, a pointer to next. Let's look at what this is. I also like this because you don't have to keep going between like go to the Linux source, which may have a lot of crazy stuff. Oh, good. This is just a pointer to a message. Oh, this is just like a next pointer. Okay, sweet. How did this work again? mlist can pointers to messages in the queue. That's the thing on the top. MTS determines the size of the message text. Great. Alloc message. All right, sick. Okay, so we need to figure out how alloc message is called. I kind of want to dig through the Linux source, but we only have 45 minutes from now, so let's go look. Redirect me, please. Okay, great. Alloc message. And copying the message. So first get the length. If the source is greater than the destination length. Copy. Oh, so these messages are supposed to be like everything after that. So it's actually supposed to be like a message is that. So it's the size of this message and then everything after that. So let's go back to the allocation point. So allocate a message of the size length. Yeah, so the size of star message plus a length. The length is the minimum size of a message or the length. sick. Okay, so what this means is that the way this structure is going to work is that first we have the struct message, and then we have a size after it. Cool. And thank you. So it's message send. And that will mean that we don't have to keep walking past this. We can also see like exactly how this is constructed, and sometimes you actually need to read through this stuff to make sure. You can look at the types, make sure the types are all correct. Message send. Good old friend, the man page. Okay, bang, copy some code. Much rather copy from a human than ChatGPT. Okay, so we need, and this is important to understand, now that we understand exactly what's allocated here, to guarantee, and if you've never seen this, this is what's something that's happened a lot since C code, that we do, especially when you read kernel code, is that you can do size of and use the dereference operator on an object, but you're not dereferencing the object really, you're dereferencing the type and saying the size of whatever MSG message points to, which is this struct MSG underscore MSG. So that's the message there. Okay, so what we want to do, and we know our target size, our size is hex 1D0. So we need, but we can't allocate a message of size 1D0. Why? Because it always appends this constant size of star message. So we need to make sure that we are keeping into account, and here we can tell exactly from GDB is telling us with p_type/0 exactly what the size is. So the size is 48 bytes. So we need 1D0, 0x1D0 minus 48, and 1A0 is what we're going to need to allocate in order to make sure that that goes to the correct thing. Okay, so message send. User send message to receiver from a message queue. The calling process method write permissions on the message queue. Cool. Caller defined structure. Okay, depends on copy of the message. So we have to like create a message queue ourselves. Okay, we can do that. I would like send message Linux example. Okay, don't care about your problems. Okay, so ftalk. Oh, it's system v IPC. Okay, key. Okay, it's actually pretty easy. Message send QID. Okay, I think I've done this before. QID, so you need to get a queue. So now I'm going to look at the 7. So 7 is where it like describes concepts. So message queue 7, so MQ overview 7 in section 7 is going to give you an overview of POSIX message queues, which will tell us how to do this. Get, send, receive, but oh, it's distinct from that. So yeah, I almost got too far. Shared memory? Okay, damn it. Message control operations. This is where I may steal code, but from somebody. But okay, let's just do this. So message send creates a message. Okay, but I need to get this. Message sends depends a copy of the message pointed to by a message feed. System queues removes the message. Okay, but how do I get a message queue? Sending a message. Yay, exactly what we need. An actual example. Cool. Okay, so we want so I'm gonna make a pound define. Uh, let's call this heap size D0, right? 1D0, that's the heap size. And then I want to define something called message size is minus 48, we said. Oh, because the heap, right, it's going to allocate more, so it's 2,000, 200. Interesting. Okay, yeah, let's make sure we do that. Yeah, because that's 512 if my calculator is going correctly. Thank you. All right. So we know if we do this message size, we should do that. We can double check. One of the key things is like we could actually like debug this kmalloc right here exactly inside alloc message to make sure that this happens, and we may do that. It's super helpful to make sure that this actually happens. Okay, so I don't want a struct. What I want is a char message. I called that. Of course, you define these variables. Don't know what the heck to call them. Message size. Okay, let's just zero that out. That's the message I want to send. Oh, this is like a specific type of object. Okay. Wait, no. Okay. Long example sends a message to queue identified. This call specifies an error. Should be reported. Okay. What was I using for return value here? Probably ret. Ret is equal to message send msqid, address of the message. Okay, and then we go back here to specify that, yep, this actually is the message. Okay, so applications are that the argument msgp points to user-defined buffer that contains first a field of type long, specifying the type of the message, then a data portion. Okay, great. So character text. Now the question is, of course, if that needs to be in there or the right size or whatever, but that's okay. Retrieving process for message selection. Interesting. Message right from 0 to system post maximum. Okay, so then what does type get used in here? Probably whoever calls this bad boy. Referenced in 3 files. Probably here. Nah, okay. It's getting too much in the weeds. Okay, well, I guess we can just double check and make sure that that's exactly what we think. If it's, yeah, the type variable first bytes. So this would mean struct message. So message.m type equals 1, we'll say. Oh, interesting. Okay, we have to make sure that we don't get paused when we do things. Okay, so message send, size of message. Oh, interesting. It's message.text. Huh. Okay, yeah, this must be the data format in the syst call. So that way when this must go probably, did we see the M type? Here's where M type goes. So now we see exactly. Cool. So yeah, our data does go after this message. So it basically takes our type, probably puts it here right in this M type, and then adds our data afterwards. And I'm really curious as to what that security pointer is, but let's ignore that for now. Okay. M type is 0, and we want no wait because we want this to be essentially queued up by the operating system. So we want the operating system to queue and store this message, so that way it will exist, and then we're going to overwrite it and then read it back later. So that's what we want the IPC no wait should do. Open a message queue. Okay. A message queue. The calling process must have write permissions on a message queue. Great. Message queue, message buff. Great. Messages of 0 length are permitted. The M-type field must have a strictly positive integer value. So this is what that comment somebody was just making. Okay, message send. Okay, so message control can be used to control the message queue. But why does it not tell me how to create a message queue? Okay, if receive removes a message from the queue specified by message queue ID and places it on the buffer. Great. Okay. Okay, so this is a POSIX message queue. There we go. Message get a message queue identifier. A new message created if key is the value IPC private or key isn't IPC private. Okay, cool. All right, so I can make my own message queue, it looks like. Show me an example code. No. Got, okay. Let's make sure I got that. Include types, IPC, message, H. Yeah. Let's see, and this is message get, which definitely makes sense. Okay. PT, what? Okay. It takes in a key, I see. Ah. IPC key. Interesting. Okay. Path name uses identity of the file name, but given path name. Oh, interesting. Looks like it's just a hash or something. Oh, that's how you specify semaphores. Ah, interesting. Okay. That'll be my key. Project ID. Interesting. Huh. Project ID. Okay. MS get key. Okay, where was MS get? Flags, IBC private. Okay. All right. Okay, so we should see that we get it. I want to add some debugging statements here. All right. Okay. So I'm going to do two things. Let's try this. Let's make sure we're allocating it correctly. So I want to break in alloc message. So let's see here. Yep, I'm in the VM. I'm in the VM, hopefully. Oh, because I'm debugged. Moles. Okay. And I want to get at alloc message. I don't think anything on the system should be using this a ton, so it should be pretty easy. Okay, if that did not work. Oh, haha. This is a fun, very fun. So because this is static, it means that it doesn't, and static in C here means that it's only used in this, whatchamacallit, in this file. So oftentimes it won't export any symbols, even though if you compile it in debug mode. So sometimes you need to go up a level and see like where is it actually, oops, where is it defined? There we go. So we can debug load message and we can see that it actually, oh, and this looks like, because this underscore user means it's coming from us. So it's actually like figuring out, like this is pretty close to the high level. So if we, Control B, break. Okay, so now we should be breaking at load message. We need another person in here to do magician. Oh wow, no errors. That's pretty sweet. Okay. Okay. So it should have, of course, we didn't put any output, which is super annoying, especially when you come back to code like a week later. So it's opened the drive. So now it's going to call get character. So now it's going to free. And now we should be in the ioctl. So this should be the ioctl from here into the kernel. We're going to continue. Okay, so it said going to free. It did it. Now it's waiting for us to do the next one. ftalk no such file directory. You mean it has to be an actual existing file? That's really stupid. Okay. Wait, why didn't it die? Oh, like dot like the current file? Oh, that's interesting. But see, this is why you put error messages here. Oh, duh. I know what happened because we caused a use after free and the kernel crashed. Okay. It'd be really nice if you could like snapshot this. Okay, now back up. Okay. I don't really care about the ioctl, so let's not do that. I do care about there. It didn't compile. MS-get, no such file or directory. Oh, cool. Now it destroyed itself. Oh, because the file needs to, you need read or write permissions on this file? That's crazy. Okay. Done out, and this needs to be a character. Okay, let's try that. Maybe let's do that without causing the whole thing to die. So yeah, let's do that. Okay. This of course is a good thing. If what you're doing is crashing everything, get to a state where you're not crashing everything. Okay, Brett undeclared. Of course, we just comment out a bunch of code. Boom. Okay, good. I'm in. Okay. 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 Was that the permissions was the thing in MS-Get? Thanks. I think that's what we're... Holes. Okay. Oh, IPC create. Oh, because it doesn't exist. I thought it said it would. Interesting. Okay. That makes sense. Hey, there we go. But why didn't we debug? And is that because of ASLR? Of course it was. Sweet. All right. Thank you all. Yay, there we go. Okay. What? Wait, what? How? Did I copy the wrong thing? Huh. Okay, that's weird. Five. Okay. Lols. Oh, doesn't know the base address. That makes more sense. Ah, ha, ha. It's like we're definitely there. All right. Oh, too much. Okay, but we can see where we are. We're pushing things, moving things around, pushing it, setting up the thing, and then calling this function, loading that, calling that, which if we look at the code, should be something like alloc message passing in the length. So let's break right before we do that. Okay, we're just about to call this function. Ooh, look at that. That looks sweet. This RDI is 200. So we should be then allocating. Yep, okay. So we should be calling alloc message with that length. Okay, so we can look at these. Start of the function, push stuff, move that into there. And I believe that first function should be inside alloc message, which we're definitely going to. Wait, no. Yeah. Wait, but is that a wrong size? Because this length should be. This is probably. Okay, Alec. So why is it? So length is 200 getting passed in. 200 hex, of course. Okay. And so this function, load message, should have a source pointer, a user pointer, and a length. It's probably a user pointer. We have to figure out where this is called. Here we go. Oh, do message send. We are in message get. No, we are in message send. Duh. We're sending a message. Oh, here, the message QID, the message type, which should have been extracted, mtext, the size. So if we go back one more, where are you? Buffer, message size. Yeah, that should be the. Okay, yeah, here we are way back already at the syscall. Okay, so something is messing up because our size here should be this message mtext. We're seeing it as more. Okay. 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 Get the key, get the message QID. All right. So now yeah, 464. One D0. Yeah, is it because it adds the 30 from the header? Yeah, possibly, but not yet, at least what I'm seeing. So this 30, this looks like it should be flowing down like into this function all from this size. This size should come directly from us. It's the same message size. Now here's where, so message size, if message size is greater than the size that a message could send, or if it's less than 0, or if message QID is less than 0, then return negative. If the type is less than 1, here's that check where we were talking about, then call load message, message text, message size. This should go here. So the source and length, this should allocate a message of this size. Why am I misreading it? It just happens to be. Okay. Now that's me debugging. Down. Okay, so I am in, should be in load message. Okay, print out more, compare. Let's step through it a bit. The problem is, oh, Wait. Did I have my system call? Okay. I must have had my system call messed up. Okay. Let's check. Okay. Wow. Okay, single stepping sucks. No more single stepping. I believe this call should be my allocate. Best way to check is just try and receive the message. Oh, no. Best way to check is the debug. I disagree. I want to make sure the kernel's code is doing exactly what I think it should be doing. Okay, so this should be calling alloc kernel. Yeah, because we're in alloc message. And great. Should use system V, right? I always need to look this stuff up. Yeah, so RDI, okay. Oh yeah, and RSI. Ah, these are, okay, great. Hey, so here's one thing we can look at that's great is the flags. So this should be interesting. GFP kernel account. Okay, so it is allocating 200 hex bytes into, and those are the arguments that it's passing. Now we can step over that and it should give us the value. Now RAX has the value that was extracted. Okay, so I'm going to, and then of course it will, oh no, it doesn't stay there forever. Oh no. Okay. Cool. Okay, so I'm fairly certain this is allocating correctly. So now let's think about how we know the heap works. Yeah. Okay. So this means what I really want is, and now we can test. So let's test that and this is when we call open, it allocates from there. So we need to hook, we want to hook either kheap open so that we can figure out what this private data is, or we can do the ioctl. Yeah, we can do that when we free it. So we can check that we're freeing this ioctl and we'll see if this is going to be the right value. Okay, cool. Okay, let's add in that code back in. I'm not sure I want to do this writing. Okay. It doesn't matter because as soon as I do this, it's going to, although if that I properly did it, it probably won't crash. Anyways, so what I want to do now is double check that. So I'm going to free that pointer. That should go into the free list, and that should be, I can't remember, is the free list. Yeah. Okay, let's just see what those pointers are. Oh, great, I'm already here. And now I don't need to change the whole thing. Okay, but now I want to make sure that I am breaking on. Of course, I can't check if I am. And okay, so load message is 1, and I want to do on open. Yeah, no, on, yeah, let's do open. Should be the second call. It should be very easy to find. Okay, so now this should be on open. So yeah, the first call is the call to print K, and the second call should be the call to K malloc. And what I want to do is debug right after that, so I can get that value. Oops. Okay, so that's what it was returned. I may have stuff in Scratch, let's say. Okay, so the private data. Okay. Going to free. Okay, free that. And then we should be allocating. Now, C5, this should be the load. And what does that return? So load. So alloc message, load message also returns a pointer to a message. So if we did this correctly, it should be roughly the same. Let's go up. Let's okay, that's where we want to go. Yo, there we go. All right, sick. Exactly what I knew was going to happen. I wasn't worried about it at all. Okay, so now that we have that a message, now that we have that allocated exactly the same location, so there are 2 pointers to this data, right? We have private data, which we can overwrite onto, and we have this message. So now that that is here in the kernel, now we can do, so we can do message send. Now when we overwrite it, what we're changing this is to all A's, which is probably going to mess us up. So we can actually maybe test this. Is that possible? Let's see. Okay. We could do to have a function malloc. Okay, nope, don't want that. So p type -o, nope. So I would guess, since we don't know any pointers, we want to overwrite these with null bytes. And actually, what I'm going to do is copy this bad boy into here of what I'm going to overwrite. Not like that though. Actually, maybe it will be like that though. So struct message has that, has that. Let's just compile. Oh, this is a pointer to this. So now, if we want to be able to dump out a bunch of memory and read arbitrary memory, what we can do is then control this MTS. So we know MTS should be 1D0, and that will read out 1D0. So we will, and actually we don't want to change next or the security pointer as we overwrite it. So essentially what we're going to do, and actually how does our copy work? ioctl, okay, so it's just a straight copy from user. Great. So what we want to control is the list head. So we want 8 bytes, 0 bytes, 0 bytes. And then, actually, I'm just going to do void pointer next, void pointer prev. And then along of the type and the size, and message header. That's what I'm going to say, because that's what we're going to be our header. So we're going to delete the next and the security. And what we're going to do, we want this to be, let's see, can I do something like this? I can't remember struct literals. No. Yeah, like that. Cool. Okay. That doesn't feel right. Compound literal. Bah. Test that. Okay, test that. Oh no. All right. All right, now that should overwrite it, and then read back the message received. I know we're over time. I'm just going to go slightly longer because I really want to do something. like no errors with my messages, please. And I obviously don't want to wait because I know there's got to be only one message here. Dang. Of course, while I was doing that, I should have got this going. Type before which buffer? Was one? Oh. I think it's just a void pointer, so I think it doesn't matter. Because we're asking it for the type, so it should just put back, but let's see. Oh, interesting. Maximum size in bytes to the number text structure pointed to, but if the message text has, oh, pointed to, I see what you're saying. Yeah, it is the same format. Nope, you are correct. It's gotta be. Oh, there's already a C get car. Okay, so if this works, I should be able to send back like 1,000 bytes to and thank you. So that should fill in with this text because we've overwritten the 1,000 here. And this should then allow us to get a nice primitive. Okay. To do some arbitrary reads. Okay. Oh, I guess I shouldn't do VM stop within the VM, although that does work. It's kind of insane. Okay, and I guess in this case, I think it should work correctly, so I'm just going to debug the program itself. Okay. Okay, now we're doing everything from user space, debugging from here. Okay, now we know it should kind of work up to a certain point, right? The ironic thing will be, of course, if my debugging this causes extra messages to happen and be okay. So I am fairly confident that everything works up until our message received. So let's just double check here. Oh, that's the overwriting it. I think that actually still is fine. Let's just break. Boom, 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 does the overwrite. Uh-oh. I keep thinking, what is it doing? Okay, going to write. Yeah, VM logs. Okay, great. But it was actually because our own program. This is the problem when you just add things into your program to like, oh, wait until I hit enter if you don't have an output to remind you that it's waiting for you. Very annoying. Okay. Now, message response. So, okay, yeah, because that's going to be written into. The important thing is the 1000 here. So let's see what happens. Kernel panic. Okay, great. Cool. Null pointer dereference. That's not great. 8. So it's clearly probably do message received. And let's see. Yeah, so that's a great point. So we can actually see where it broke up. Do message receive. And we had the code. We were looking at the code here, or we had it in here. Yeah, so this is part of the fun thing of doing this is you do this, you think it should work, it doesn't work, and then you see why. Like you're gonna have to figure out why. Um, and that involves reading the kernel code. So one thing I do is look at where is do message receive, but I actually know so I can see do message receive. It's got to be in here somewhere. Yeah. Do message. There we go. So, and this is part of like doing this kind of stuff really involves reading a lot of code. And if you take my 598 next semester, you will realize that as well because we'll be doing that a ton. So, okay, so looks like it's roughly the shape of a handler here, of a syscall handler. So we have our message queue ID, the buffer that's still in user space, the buffer size, the type. So this all looks like stuff from us. So message flag, and message copy. I probably should have done that so that it would copy it out. I need to check exactly what that flag does. Oh, taking it out of the buffer versus copying it out of the buffer. Okay, that shouldn't matter, but who knows. Okay, now it's looping over shit. If it's an error, found a suitable message. Okay, if buffer size is less than TS, this is when we don't have enough size. That's what I passed in that message no error just to make sure it wouldn't be that. If we are copying, then do not unlink message and do not update queue parameters. Oh, this may be our solution. So just copy message, go to out unlock 0. That's probably towards the end. Yeah, I bet we could get around it by just asking it to copy that message out so that the message stays in there. I think because what it's doing is exactly what Danny mentioned in the chat of it's probably like taking the message that it found, right? And then figuring out, oh, the list, delete it from the list and then subtract this and then do this and then update all these counters, and it has to go to next and previous, but our next and previous were empty. And so that's why we got that problem. And it did not think that a message should be 0. Let's see in the slides. Yeah, copy message. Cool. So that is why we want to do that. Let's see. Oh, just because I like. Okay, so message copy will leave a copy in there and just copy everything to us and to our message. And that's what we really want to have happen here. Message. Yeah, interesting. The longer you spend in these things, the more you kind of understand them. It passes in a function handler called message handler. That's interesting. Message copy undeclared, first used in this function. Okay. Non-destructively fetch a copy of the message at the ordinal position in the queue, specify message type. Message should be numbered starting at 0. Okay, that's annoying. Function with IC don't wait. Holds immediately. If the error because they alter the meaning, message type of talking ways, message copy message accept. May not be both specified. Ugh. Okay. Why can't I use this since Linux 3.8? Yeah, that should work. Okay, what was that error? Just copy that error. Aha. Compat.h. Okay. Well, this is not working. Okay. Yeah, they're Linux specific. Great. I want to use them. By defining the definition is going to be taken by defining the feature test macro. How do I define? Something like this. Ooh, I'm getting to. Oh, that worked. At least the compilation, of course. Let's not get it too ahead of ourselves. And I think it said the ordinal position, so that means the type that I'm passing in the receive should be 0, because I want the 0th one. Okay, and I want to break on line 165. All right, maybe this will work. Maybe it'll break. If it breaks, then we'll have to figure out, yeah, we need ring 0. So like those addresses need to be some kind of kernel addresses, the next and previous. Be interesting to see if something happens to them. But anyways, we would read the code. We'd figure out exactly what happens. We would make sure that this fake object that we're constructing has the proper parameters. We'd also probably go, my next instinct would be to go look at some, I know some of these exploits, like this one, leveraging message definitely does this. And whoops, going to free, going to right, breakpoint. Hey, it worked. Okay. X. And it's cool. So we can see that there's definitely pointers leaked here. So we, although those are user space pointers, why are those user space pointers? 1,000, not as much as I wanted. Those maybe look like kernel pointers. Yeah. Cool. Okay, so we effectively have now like an, did I, yeah, I have 1,000 hex bytes, so I even have more. Cool. Okay, so I'm dumping a ton of stuff from there. And now let's look at this challenge. Um, cool. Cool. So basically, this is leaking a ton of information about the kernel. So I'd figure out what are these values. Like, I mean, clear break of ASLR in here, right? We have these things in here. So I probably run it a couple times, see how deterministic this is, and then now I have from that point in memory, so from that allocation, so now that I can control this size, I don't think there's any limit to the amount of size here. So you can use this now as an almost arbitrary read. I don't know if it's fully arbitrary. Let's see. Yeah, so great arbitrary read. Slice the buffer to process, do shorter segments. Cool. So yeah. So I think this is the key thing is like, yeah, so look this. Um, overwrite next. Ah, interesting. Cool. Yeah, so my plan would be read all this stuff, figure out exactly what to do. I think this is really cool because we're already overwriting the structure and we can overwrite it multiple times, right? Because we have that overwrite and we've been overwriting here just type and MTS. So I would assume this link would tell us, hey, this is how you, if you're first doing this, like now by changing the next pointer, so this next pointer will point to another message header that if you can control exactly where that goes, you can then leak much more information. So the important thing, I actually remember reading about this, is the cool. Um, oh wow, this is maybe before that technique was widely known. Um, hmm, yeah, cool. Okay, I gotta go. Shoot, I'm going way over. All right, good luck. Bye.